Okay, this video should introduce integration. Before we get into integration, let's quickly remember what the rules for differentiation. So to differentiate, I multiply the coefficient and the exponent first. So 3 times 3 is 9. And then I take 1 away from the exponent. So that becomes 9x, 3 minus 1 is 2. So 9x squared. For this one as well, I'm going to multiply the coefficient, which is 12, by the exponent, which is 2, which gives me 24. Then I'm going to take 1 away from the exponent. So that becomes 24x to the 1, which is just 24x. In this third case, I have to do some maths first before I can differentiate. So I'm going to rewrite this as x to the power of 1/2. And then I'm going to differentiate. I'm going to do 1/2 multiplied by 1. There's a hidden 1 there at the front, so that's 1/2. X to the power of 1/2, take away 1/2, take away 1, sorry, is minus 1/2. For this last one, I've got to do some mathematics as well to rewrite this in a form where it can be differentiated. So this becomes x to the power of minus 1/2. So again, if I differentiate, I multiply minus 1/2 by 1, so minus 1/2 x, and then I have to do minus 1/2 minus 1, which is minus 3/2. Now, so here are the rules for differentiation. We see that we're multiplying the coefficient by the exponent, and then we're taking 1 away. So let's look at this one last example here. So I've got 2 times 3 gives me 6, 3 minus 1 gives me 2. Now, integration is the opposite of differentiation. So what it means is I start with my gradient function here, so f dash x or dy over dx, and I'm going to perform some operation which will recover my original function, so f of x or y. So we're doing the opposite of differentiation, so to integrate we're literally going to do the opposite steps in the opposite order. So let's have a look. So here I have, tell you what, let's start with this one. Here I have 7x cubed, so let's use our differentiation skills. We're going to multiply through, so we're going to go 7 times 3 is 21, x to the power of 3 minus 1 is 2. Now, to integrate, I'm going to do the exact opposite steps. So here I have 21x squared. What I'm going to do is add 1 to that power first. So I'm going to add 1 to that x power, which becomes x cubed. And then, now that I have my new exponent, I'm going to do my coefficient, which is 21, divided by 3, which recovers that 7. So that 7 came from 21 divided by 3 there. So I do the opposite steps in the opposite order. So let's have a look at this one. To differentiate, firstly I have to write this in a form where I can differentiate. So that's x to the half plus x squared. And then differentiating, I have 1/2 x to the minus 1/2 plus 2x. So here we go. What I'm going to do now is I'm going to do the exact same steps in the opposite order. So firstly, I'm going to add 1 to both powers. So x to the minus 1/2. Minus 1/2 plus 1 becomes x to the half. And then my leading coefficient here will then be 1/2 divided by 1/2, which is just 1. So we've got x to the half here recovered. And then plus, I've got x to the 1 here, so I'm going to add 1 to that x to that exponent. So that's going to become x squared. And this coefficient will be 2 divided by 2, which will also be that 1. So that'll be x squared. So yeah, we can see that we've got back to the original function there again. So we're reversing the steps that we're taking. Let's look at this one. Differentiating, I have 1/3 times 3 gives me 1. So that's 1x squared. So I have x squared. I'm going to add 1 to that power, so that becomes x cubed. And then I'm going to divide 3, so that's 1 divided by 3. So yeah, we can see how our integration is recovering our original functions. To integrate, add 1 to the exponent, divide the coefficient by the new exponent. If dy over dx equals x to the n, then y equals 1 over n minus 1 x to the n plus 1. If f of dash x equals xn, then f of x equals 1 over n plus 1 x to the n plus 1. The last thing we have to consider is this. Let's look at these three functions. X cubed plus 10, x cubed plus 2, x cubed minus 2. If we differentiate them, they all end up being 3x squared. There's no x terms here, so they end up being multiplied by 0 and getting erased. Now if we integrate this 3x squared here, I'm going to add 1 to that power, makes it x cubed, divide 3 by 3 gives me that 1x cubed. Now notice, I don't have any of these original functions recovered. I've got a completely new function here. So which is the original correct function, and how can we stop this process from going astray? The way we're going to do that is we're going to introduce this constant of integration, c. So what I'm always going to do, after I integrate, I'm going to add a little plus c to say that there is some constant term that I don't know whether it exists, and I don't know what it is, but I know it could be there. And so I'm covering my bets when I'm integrating to make sure that I don't make this error. So we have to always consider this constant of integration c. So f dash x goes to, integrates to, this little symbol, integral, we'll see that later, f of x plus c. So that is an introduction to the very basics of integration.